Hello guys, welcome to the video. Today I'm going to show you how to use the distance sensor with Arduino. And so in this video, I will be making a project where the distance sensor is detecting how far away something is in centimeters. So basically I'll be showing you how the distance sensor works, how to connect it up to the Arduino, and also the code it takes to get it working. So without further ado, let's get this video started. Okay, so now here is the distance sensor. To be more specific, the SR04 distance sensor. And so the first pin is VCC. This is responsible to provide positive power to the distance sensor. And then we have trig or trigger pin. This pin is for whenever you want to send out a ping, you will send this pin high. The longer you send this pin high, the longer the pulse will be. So usually we just send it high very, very quickly and turn it back low. So we don't have a short ping that goes out and then comes back once it hits something like a wall. And then the echo pin will also go high at the same time whenever you send this pin high. And it will stay high until the sound or the ping that you have sent out with this pin will come back. And then echo pin will go low. And how long the echo pin has been on, that's how long it took for the pulse to go out and come back. So we can just read that high pulse and how long that high pulse has stayed on. That will tell us how long it took for the ping to go out of the sensor, hit something, and come back. That will give us the time. Then we can know the speed of sound and divide it by 2 because it's also going out, hitting something, and coming back. So we have to divide it by 2 because it's going to the speed of sound 2 times. And that will give the distance on how far something is away from the sensor in whatever measurement you want. And then the last pin is GND. This is responsible for providing ground to the sensor. So now we'll go ahead and connect the sensor up to the Arduino. So now here is the SR04 Ultrasonic sensor. So we'll go ahead and put it on the breadboard. So now I'll go ahead and connect the VCC pin on the ultrasonic sensor. And I'm going to connect that to 5V pin on the Arduino. And then the trig pin will be connected to pin 12 on the Arduino. And then the echo pin will be connected to pin 11 on the Arduino. And then GND will be connected to one of the GND pins on the Arduino. I'm going to do the one that's next to pin 13. And that is how you connect the ultrasonic sensor to the Arduino. Okay, so now here is the code that it takes to get the sensor working. And so basically we have 4 variables here. We have trig pin, which is equal to pin 12. We have echo pin, which is pin 11. And then we have duration. This would be holding on how long it took the ping to go out and come back to the sensor in milliseconds. So that is what this variable will be holding. And we have distance. This will be actually holding the value in centimeters on how far away the sensor is from something. And then we go into the void setup and we set up our pins. So trig pin will be an output because we're sending a value to it to send the ping out. So that will be an output. Then echo pin will be an input because we're reading the pulse from echo pin to see whenever it will go down so that we know how long it took for the ping to go out and come back. And then we set up the serial monitor so we can print out the distance in centimeters. Then we go to the void loop and we go ahead and start doing things with the sensor. So the first thing we need to do is we need to send trigger pin high to tell the sensor to send out our ping. So that's what we're going to do. We do digital write trig pin high. Then we delay 10 microseconds. The pulse doesn't need to be that long because we just need the ping to be very small. All you need is like a very small ping to send out so that the sensor can hear it when it comes back. And then we turn the pin low after 10 milliseconds. Then after that, the sensor will turn echo pin high. It will stay high until it receives that ping back. And so basically all we need to do is we need to read echo pin, which we do here, and we're going to use the pulse in function. The pulse in function tracks how long a pulse stays on. So basically in this case we are reading how long a pulse will stay on, and it's going to be a high pulse. And we're going to stay here at this line of code until it goes low. And once it goes low, the pulse in function will tell us how long it took for it to go low, and it will send that time in microseconds and it'll put it in the duration variable. Then we come down here and we do duration times, so this is the speed of sound in microseconds for centimeters, divided by 2. Because since the sound, the ping, is going out, hitting something, and then coming back, we got to divide by 2 because the speed of sound is only one direction. It's not like counting for the amount of time that it will take for the ping to go back. So we have to divide by 2. And this will give us the distance of how far something is in centimeters. And we're going to put that value into distance. And then we'll go ahead and print that out on the serial monitor, and then we'll wait a half a second and then come up to this void loop and do it all over again. And so now that's the code. So now let's go ahead and see our project in action. Okay, so now as you can see here, we have a ruler right here, and we have the sensor right here. And so now you can see the values that the sensor is giving us on the serial monitor. These numbers are in centimeters. So I'm going to go ahead and place something in the way at 5 centimeters. And as you can see, the sensor is reading 5, 4. You kind of have to make sure this is straight for the correct reading. So right now it's 5 centimeters. We'll go back to 6. As you can see, we have 5 centimeters. If we go a little bit back more, we got 6 centimeters. So we have 7 centimeters right here at the 7 centimeters mark. Then we go a little bit more to 8 centimeters. We see 8 centimeters. Go back to 9. We have 9 centimeters. And let's go all the way to 12. As you can see, we have 12 centimeters on the serial monitor. So basically that is the project. If you like this video, consider giving this video a like. Also comment down below if you have any questions, and consider subscribing if you want to see more content like this. Thank you all and have a great day. Bye.